Okay, so I want to talk about a few more things with conditionals, just, to get the ideas on the table. And then, I think next lecture we're going to start talking about some of the more interesting stuff we can do with conditionals, some of the more interesting issues that they sort of highlight with the way we use ordinary language and ordinary arguments, and some things that they'll make us aware of. But just a few more things I want to get on the table with the conditional before we can do that. And the last of these is something your book spends a little bit of time on, but I'm going to go into a little more deeply. And that's this idea of a hypothetical syllogism. So, hypothetical syllogism is an argument of roughly this form: if A, then B; if B, then C; A, so C, right? Or you might even, if you want to really spell it out, you might, as your book does, put a sort of intermediate step here and say, well, if A, then B, and if B, then C, you also get if A, then C, right? You guys can kind of see how this form of argument works. You can kind of think of it like dominoes falling, right? Well, if you have A, it gets you B, B gets you C. So anytime you have A, you're going to have C as well, which means you're going to have this conditional: if A, then C; if you have these two, if A, then B, and if B, then C, right? Look, if you need a truth table to spell it out, and, the book spends a lot of time with the truth table, so it's worth, saying a little bit about this. Look, you can just see on these lines, every line of the truth table where the conditional if A, then B, and the conditional if B, then C is true, the conditional if A, then C is true as well, right? Anytime you have these two statements, you're going to get this if A, then C conditional is going to be true as well, right? Lines 1, let me count here, 5, and 7 and 8, you can see when these two other conditionals are true, your if A, then C conditional is true, right? Shows you, if you want the truth table proof, this is why this form of argument works. Anytime you have these other two, this final one will be true as well. All right. Just to make this clear, we can go with an example, right? I'm not going to give you guys the symbols. You can add them if you want. You guys can add them if you want to, but I'm not going to do it. If Sam does an exercise, then his blood pressure will be high. You could say not S, then H, right? Sam's blood pressure is high, then he'll get a lecture from his doctor, H, then D. Sam won't exercise, not S, so D, right? If all this is true, then just down the line, you can see this. Now, something interesting with the hypothetical syllogism that your book doesn't really make enough of a deal about, doesn't really talk enough about, is that we can run this in the other direction. What do I mean by that? Well, take this argument, right? Sorry, I'm just thinking back to a lot of punditry in 2016. If Hillary Clinton does as well as Obama with working class voters, she will win the Rust Belt, right? Sorry if one of you guys is from Pennsylvania, Wisconsin, Michigan, any of those states, just handy. I like Pennsylvania. A lot of my relatives live there. No aspersions against Pennsylvania. Just people refer to the states as the Rust Belt a lot, right? Anyway, just to save myself some effort, I'll use that phrase. So if H, then R; if R, then W. If she wins the Rust Belt, she'll win the election. W being win the election. Well, Clinton did not win the election, not W. Therefore, Clinton didn't do as well as Obama with working class voters. Not H, right? Now, I'm not saying this is a cause here. Obviously, her not winning the election didn't cause her to not do all these voters. It's the other way around. It's just from the fact, if these other statements are true, then you know she didn't do as well with these voters as Obama did, right? If it's really true that if she did as well, she'd win, and she didn't do as well, she didn't win, then you know she didn't do as well, right? So why does this form of argument work? Well, I'm not going to give you guys a truth table. We could do that. Those get a bit boring, right? Now, of course, a lot of you guys have just an intuitive sense why this argument works, right? But I think it's good to spell it out, right? If we're not going to do the truth table, let's think about this in terms of valid forms of argument, right? So remember, one of the things we talked about was the contrapositive, right? This was how modus tollens worked, right? If A, then B is logically equivalent to if not B, then not A, right? Remember we did the truth tables a few lectures back. These statements have exactly the same truth conditions. For the purposes of logic, they mean the same thing, right? You can treat them interchangeably. When you have one, you have another, right? Well, so let's look at the statements of our argument and just use the contrapositive, right? Well, if H, then R, logically equivalent to contrapositive of that is if not R, then not H, right? So we can just treat premise 1 that way. We just get the contrapositive from that, right? Premise 2, if R, then W, well, contrapositive, we can just treat if not W, then not R the same way, right? So premise 1, we can get if not R, then not H. Premise 2, we get if not W, then not R. Well, then we'll just add this premise 3. We have these two conditionals. If not W, then not R. And if not R, then not H. Well, now that we've got those two, we just use our hypothetical syllogism. If not W, then not H. Not W, so not H, right? When we spell it out that way, hopefully you guys can get the pretty rigorous sense of why this works without us having to go through all the bother of a truth table, right? If you're this addicted to truth tables, you can write the truth table for this to see why this is a valid argument. I hope this serves just as well, right? Intuitively, you can kind of think of this as just zipping back, right? If A, then B. If B, then C. Well, not C means you can't have A either, right? It just kind of zips back. Well, we'll see that this is actually, when we start talking about refutation next week, we'll see that this is actually a pretty useful, pretty important form of argument. All right. Hopefully I haven't needlessly complicated something simple. There's always that risk with logic, but I just want you guys, to see exactly why this works, right? I do agree with the book that, having a feeling why it works is one thing, spelling it out exactly is another. Okay, final thing I want to talk about with conditionals is the biconditional. Your book mentions these. It doesn't actually give a symbol for them, right? I think they're important enough that I'm going to give a symbol for them, right? Now, you can just represent the biconditional by saying if A, then B, and if B, then A. It means exactly the same thing. You can do that. That's what your book does. I think these are important enough. They're common enough. They're not as common as, conditionals, but they're common enough. I think it's worth, having this symbol just to save ourselves some work, right? The symbol is like this little arrow that points both ways, right? Ordinary English, the biconditional says if and only if. Sometimes philosophers and mathematicians will abbreviate this with as IFF. That's not ordinary English, but this comes up enough in philosophy and math that people will do that. We're not going to do that. Just, every time I give you guys a new symbol, I do like to do the truth table. So look at the truth table. This one, if either, it's false when A and B have different truth values, right? If A and B are both true, the biconditional is true. If A and B are both false, the biconditional is true. When A is true and B is false, biconditional is false. When A is false and B is true, then the biconditional is false as well, right? Now look, we don't actually say if and only if that much in ordinary English, right? You're going to see this a lot more in philosophy or math or legal contracts where people spell things out this way, right? In ordinary spoken English, we actually very rarely say if and only if, right? I don't know, you're signing a contract, you might want to put that in there, but we rarely say it, right? But the thing to notice is this is actually often implied in a lot of statements. And this is actually one of the things that makes translating conditionals a little tricky, is that a lot of times some things that look like a conditional are actually biconditionals. And I'll give you guys an example of this, right? So, I don't think I brought this up before. I'd thought about bringing this example up in previous lectures, but I didn't want to confuse you guys. But I don't think I did. But let's think about this example, right? So, let's imagine that we have, a child, a fairly young one. Let's imagine 6 or 7 years old, and he doesn't want to eat his vegetables, right? And we say, look, if you don't eat your vegetables, then you won't get dessert. If Johnny doesn't eat his vegetables, Johnny doesn't get dessert. Would it be fair to symbolize that as not V, V standing for eating vegetables? If not V, then not D, right? V, Johnny eats his vegetables. D, Johnny gets dessert. If not V, then not D. Well, it seems like it would be, right? Seems like that's a perfectly good way to symbolize this statement. It's actually not, though, right? Well, why not? Well, think about this, right? Remember, if the antecedent of a conditional is false, then the conditional is always true, right? Antecedent being the first part of this if-then statement. So, in our statement, if the not V is false, the conditional is literally true no matter what you plug in for D, right? So, not V is false whenever Johnny actually eats his vegetables, right? So if Johnny eats his vegetables, doesn't matter what we plug in for D, right? The conditional would be true. Well, think about it this way, right? It would matter a whole lot to Johnny, right? If he eats his vegetables and we don't give him dessert, we say, well, no. I said if you don't eat your vegetables, you're not going to get dessert. I never said that if you do eat your vegetables, you will. I mean, you're going to have a temper tantrum, right? And the temper tantrum will, in this case, be deserved, right? We pretty clearly made the deal with this kid. If you don't eat them, you're not going to get any dessert, but if you do, you will, right? We couldn't say to the kid, oh, no, look, you're committing a logical fallacy, Johnny, let me tell you no, right? Johnny would cut a fit. And the reason is here, despite what we say, what we actually mean is a biconditional, right? We are implying if and only if. What we say when we say if Johnny doesn't eat his vegetables, then he won't get any dessert. What we mean by this statement is he will get dessert if and only if he eats his vegetables. V if and only if D, right? Now, one thing to notice here, I just put them in this order because that's the way the statement is in English. With the conditional, it matters what order you put your letters in. It matters what's the antecedent, what's the consequent. You guys will notice with the bi-conditional, it doesn't. You can reverse these, won't matter a bit. One final example, again, something, a promise you might make to a kid. You may get a dog only if you have straight A's this semester. We'll talk about what this only if means literally in the next lecture. We'll talk about sufficient and necessary conditions. But sometimes even if we say only if, what we're actually implying is not just only if, it's this if and only if statement. You may get a dog if and only if you have straight A's this semester. If you have straight A's, if that's true, it's also going to be true that you get a dog. If you don't have straight A's, it's going to be true that you don't get a dog, right? Same as with Johnny. He eats his vegetables. Well, then it's going to be true that he gets dessert. If he doesn't eat his vegetables, then he's not going to get dessert, right? So again, hopefully you guys can see how this bi-conditional works and why it's important that we have it on the table and that we see that not all statements that look like conditionals are conditionals. Some of them actually are bi-conditionals. Okay, so that's all I wanted to talk about for this lecture. Next series of lectures, I want to talk about sufficient and necessary conditions. And again, I think this is going to be something really important that conditionals will help us to understand a bit better. And it's going to really help us next week when we start talking about arguments by refutation, this really important form of argument that you can make using conditionals. All right, well, that's really all I want to cover for this lecture. Hopefully that all makes sense to you guys. Again, as I keep emphasizing, if you have any questions, if you have any issues, please do email me or otherwise message me or call me. We can talk through them. All right.